In this session, we're going to solve the tutorial sheet on functions. So the first question is saying the function f is given by f of x is equals to x squared plus ax plus b, where a and b are real numbers. If f of 1 is equals to negative 3 and f of negative 2 is equals to negative 6, find the values of a and b. So we are saying the function f of x is equals to x squared plus ax plus b. Okay, then we're saying f of 1 is equals to negative 3, then f of negative 2 we're saying is equals to negative 6. Then we're told to find the values of a and b. So let's start with the first condition, f of 1. So what this means is that wherever there is x, we'll be replacing 1. So it will be 1 squared plus, a, again, this is a, where there is x is just 1, plus our b, like that. So 1 squared, that is just 1. So, okay, so it will be 1 plus a plus b. Now we're saying f of 1 is equals to negative 3. So our f of 1 in this case will be negative 3 on the other side. So this is our first expression. Let's solve the other expression, f of negative 2. So we're saying f of negative 2. So wherever there is x, we'll be replacing by negative 2, and this should give us negative 6. So let's start. So it's negative 2 squared plus a, okay, negative 2 plus b, okay, plus b, like that. So we're saying our f of negative 2 will be, okay, negative 2 squared, that will just give us a 4, minus 2a plus b. Now we're saying our f of negative 2 is equals to it's equals to negative 6. So this will be negative 6 is equals to, okay, 4 minus 2a plus b. Now if we put the like terms, this are 4 and negative 6, like that. If we take the 4 to the other side, it will be negative. So negative 4, negative 6, that will just give us negative 10. This negative 10 will be equals to negative 2a plus b. Okay, now we have two expressions with us. So let's start. Okay, so which one are we going to start with? Okay, this one we didn't even simplify it further. We can also take the 1 to the other side, it becomes negative. So this will be negative 4 is equals to a plus b. Okay, so we've got two expressions, this one and this one. So let's just leave these expressions, we wrap the other parts. Okay, so this is plus b. Okay, so now what are we going to do? We've got negative 4 is equals to a plus b, negative 10 is equals to negative 2a plus b on the other side. Okay, let's get one of the expression. Let's make b the subject of the formula in this case. So our b will be equals to negative 4 minus a. When you take the a to the other side, it becomes a negative, right? Yes. Then what are we going to do? We are going to substitute b into this equation, right? So this equation, we've got negative 10 is equals to negative 2a plus b. Okay, so let's replace. So say negative 10 is equals to negative 2a. Okay, our b is this expression, so we're going to put this expression plus negative 4 minus a. Okay, So now let's solve. Let's just rub here. Okay, let's solve. So of negative 10 is equals to negative 2a. Let's say it's negative 4 minus a. Okay, then what are we going to do? We're going to put the like terms together. This negative 4, when it goes the other side, it becomes positive. So that is negative 10 plus 4. That will give us negative 6 is equals to, here we remain with negative 2a and negative a. That will just give us negative 3a. For us to remain with our a will just be equals to 6 divided by 3. That will be 2. So we found our a. Now let's use a different color to find our b. We had an expression, this one, b is equals to negative 4 minus a. So say b is equals to negative 4 minus our a. In this case, we found that it is 2. So we'll put our 2 here. So our b is equals to negative 4 minus 2, that is negative 6. Hence, our solution in this case will be a is equals to 2 and b will be equals to negative 6. Okay, let's proceed to the next question. Okay, so the next question was find the range of each of the functions for the given domain and state if the function is a one-to-one or not. Find the range of each function for the given domain and state if the function is one-to-one or not. Okay, so our first function is okay, let's start with a. We're saying f of x is equals to 1 minus 8x, and they've given you the domain. The domain for this one, you're saying it's all real numbers, but it's from negative 2. X is in between negative 2 and 8, like that. This is our domain. Let me say, okay, our domain. So we're told to find the range. They've given us the domain, but told to find the range and to state if the function is a one-to-one. Okay, so to find the range for the first one, so we'll start with at x is equals to negative 2 and at x is equals to 8. Let's start with at x is equals to negative 2. So our range at x is equals to negative 2 will be what? So say f of negative 2 will be equals to 1 minus 8. Since we are saying at negative 2, so our x will be negative 2 here, so it will be 1 minus this will be positive. When you multiply 8 multiplied by 2, that will be 16, right? Okay, so this will give us 17. This is at x is equals to negative 2. Then what about at x at x is equals to positive 8? So say f of 8 is equals to 1 minus 8. Then we're saying it's, x is equals to 8, so it's 8 there. So you say 1 minus 8 multiplied by 8, that is 64. Okay, 1 minus 64, that is negative 63. So our range in this case, our range will be equals to one or values starting from negative 63 to 17. Note I've put inclusions because the symbols here, they are being included. That's what we're talking about. Okay, they are equal. X is greater. X is greater than or equal to negative 2, and x is less than or equal to 8. So now you realize that this is a linear function. So it means everything exists. Whatever number that you put for x here, everything exists. So we find that the function is a one-to-one. So this one, we found the range, and it's also a one-to-one. Okay, let's solve the next one. Okay, let's just rub this. Okay, let me just create another page. Okay. Okay, so our next question is f of x is equals to 3x squared minus 6x. Your domain in this case is x is a member of all real numbers, and the domain is from -2, okay, like that. Okay, so now how do we solve? Okay, we're going to do the same, but now this one is a quadratic function, and look at the symbol. We've got a 3, we've got a positive number on x squared, so this means that the function opens upwards. It opens upwards. So now this function will have a vertex or a turning point. And how do we find the turning point of a function? We say x is equals to -b over 2a, and in this case our negative b is this one, right? -6. So it's -6 over 2. Our a in this case is 3, right? So 3. Okay, so we have 6 over 6. Okay, this will just give us 1. So at the turning point, the value of x is 1. What about the value of y? So we'll get the same function to find the value of y. We'll say f of 1, 3. We're getting this whole expression, but wherever there's x, we'll be replacing 1. So f of x is equals to 3 1 squared minus 6 1. So f of 1 is to give us this would be 3 minus 6. This will just give us a -3. So we've got 1 comma -3. Now how do we now find the range, the other x value? So what are we going to do? We're going to equate this expression 3x squared minus 6x to 0. So let's just do that. So we have 3x squared is equals to, actually we've already been given there is -2 here and 4. So these are the ones that we put in the equation to find the values of y in that case. Okay, so let's just do that. They've already given us the domain in this case, which is even good. Okay, so what are we going to do? We are going to let's start with the first -2. So say f of -2, we'll put it in the actual function, which is 3. Wherever there is x, we're putting -2. So -2 squared minus 6, minus 2. Okay, so when we solve this side, what are we going to have? Here we have, -2 squared, that is 4. 4 multiplied by 3, that is a 12. Okay, then -6 multiplied by -2, that is positive 12. So our answer for the first one is 24. So okay, we found 24 for the y value on the other side. So our range in this case will just be, I'm sure if we're also going to try 4 in here, it might also give us 24, because the range is just from from one point to another, and we can't have 3 like that. So in this case, if we put 4 here, it will be let's say it's 4, let's say 4 squared, that is like 16 multiplied by 3. Okay, 16 multiplied by 3, then you're subtracting 6 multiplied by, that's 24. Okay, 60, yeah, like that, and you're going to solve like that. Okay, so it means our range in this case, we're just going to get this value and this value. Okay, in this case we're going to get, okay, let's try this first one. We see if it really balances as well. If we say 3x, x in this case we're saying is 4, so it's 4 squared. Okay, 4 squared minus 6 4, that is that is 4 squared. 4 squared, that is 16. 16 multiplied by 3, that is 48. So 48 minus 6 multiplied by 4, that is 24. 24 multiplied by 48 minus 24, that will also give us 24. Okay, so it balances. So our range in this case, our range in this case, let me just erase here. So it means our range in this case, okay, so our range will be from -3 at the vertex, okay, to 24. You're getting the smallest value to the largest value. Now what are we going to put in? This is from -3 to 24. Okay, why are we saying that? Because yeah, like that. Actually, that's our range. Then the function, is it one-to-one or it's not? Actually, this function is not a one-to-one. It's not a one-to-one. It's not a one-to-one. Why? Because it's a quadratic. It's a quadratic equation like that. Okay, let's solve okay, let's solve another one. Okay, okay, let's go to question 3. These are the ones you solve. It seems like we have a lot. Okay, let's go to question 3. We're taught to find the domain of each of the following functions. Find the domain of each of the following functions. And the domain is just like the range of x values. So we're taught to find the domain of each of the following functions. So let's start with the first one. Okay, let me use the next page to avoid. Yes, so let's start with the first one. So the first one, it was f of x is equals to the square root of x squared minus 4. So how do we solve this one? So the square root function is defined only if the expression inside here, inside the square, is non-negative. You don't want to have a negative in the square, because you don't want to have like a situation where you have a negative number, because you know that this one is a complex it's a complex number like that, and that's what you don't want. So okay, so let's do that. Now let's solve. So what are we going to do? So we're going to equate this whole expression in the root to be, it should be greater than or equal to 0, because you don't want an expression where we have a negative in the root. So we have x squared minus 4. This should be greater than or equal to 0. Okay, so now how do we solve this one? So let's factorize the inequality. So this will just be x squared minus 2 squared is greater than or equal to 4. Then now we're going to factorize. This is just the difference of 2 squares, so it's x minus 2 or x plus 2. This should be greater than or equal to 0. Therefore, what this means is that x itself should be less than or equal to -2, or x itself should be greater than or equal to 0, actually, to 2 actually. On the other side, when the other 2 goes, the other side should be 2, because they have got different signs, so they're just like exchange. Now these are the critical points on our graph. If we were to do our graph, okay, not really drawn to scale, but just get the concept. Since this is this is x squared like that, so it means the function opens like that. Okay, now if the function opens like that, we're saying we've got our critical points. We've got -2 and 2. Let's say this is -2, and on the other side this will be it will be 2. And now our turning point in this case, this is the line. On this line, x is equals to 0. X is equals to 0 on this line, on the y-axis. X is equals to 0. Then this is the x-axis. So now on this line, and this is where we are having our turning point here. So if we're having our turning point here, okay, and we have a value on this other side, if we place a 0 throughout to find our y value here, it will just remain with 4. So here on this, our turning point will be 4. Let me say it will be -4 comma it will be 0 comma -4, actually 0 comma -4, if we were to draw the diagram. Now we have to determine where where our solution set will lie, because we're trying to find the the range. Actually, is it the domain? Yeah, the question was asking us to find the domain actually. So how are we going to now find the domain? Actually, we've already found the domain, which is this one, but which are these values, but we just want to confirm where our solution set lies. Okay, so if we got a number that is let's say less than -2 here, less than negative, let's say we get -3, this -3 we put it in this expression x squared minus 4. Is it going to give us a negative or a positive? So you realize if we say -3 squared, that will just give us 6, right? -3, that will give us 9. 9 minus 4, that is like 5. So the first expression, it will give us in this scenario to give us a positive. Then when you come on the middle, okay, if we get a number between -2 and 2, what are we going to have? Is it going to be a positive or a negative? Let's say we get 0 and replace in this equation. So this one will give us what? A negative, because 0 squared, it's 0 squared minus 4, like that, and to just give you a negative. So in this interval we have a negative. Let's now try the other one. Okay, we're saying in this interval to be a negative. What about if we get a number that is greater than 2? Let's say we get 3. If we put 3 where there is x, we say 3 squared minus 4, that will just be 9 minus 4. That would give us a positive number. So this one will be a positive. So our solution set, the solution set that we want is on the positive side, this positive and this positive. So how are we going to now show that as a domain? Okay, so let's show that as a domain. So in terms of sets, okay, so let's use set interval notation. So our domain for this case, let me say our df will be equals to, since we're going this side, so we're starting from this side and we are going the other side. So we're saying it will start from -infinity if I'm using interval notation, and at -2, and -2 is included. So say -2, we open the we close the bracket like that, union. The other solution said that we want is from this side, from this +2 going the other side. So because this is where it's also positive and this side is positive, so what are we going to have on the other side? So right, okay, so also want 2 going to positive infinity, like that. So this will be our domain for that for the first part. Let's do for the for the second part. What if b was like f of x is equals to the square root of x squared plus 9? Okay, so the expression what taught to us to find the domain. So you know that the expression x plus y, x squared plus 9 is always positive, because if we say x squared is greater than or equal to 0 and 9 is greater than 0, since the square root, the square root is always defined, the square root is defined for all values of x. The domain is, because even if I say I put in this root, because we don't want to have a negative in this root, but even if I say I put negative 1 and I say squared, it will always be giving me positive numbers. So it means the domain in this case, the domain will just be to just be from negative infinity to positive infinity, because everything exists in this scenario. So if you are going to draw this, how is it going to look? Okay, this is not drawn to scale, so because it has shifted 9 steps, so our turning point will be here at 9. So our graph will look something like that. This will be 9. This will be 0,9. This will be 0,9, like that. Our graph going in this direction, going in the positive infinity and in the negative infinity, like that. Okay, now let's do another let's also solve c. Now c is f of x is equals to 1 over x squared minus 2x minus 8. Okay, now remember the denominator cannot be 0, so we are saying x squared minus 2x minus 8, this should not be equals to 0. So what are we going to do? Let's find the our critical values. So let's solve this one. So what are we going to do? We're going to factorize. We're going to look for two numbers that we multiply. They will give us when we multiply, okay, when you say we're going to find the product, right, where you multiply the coefficient of x and this 8, okay, then you also find the product. Okay, so what are those two numbers? There's 2 and there's positive 2 and let me say negative 4. Yes, if we say 1 multiplied by negative 8, that is negative 8, and we look for two numbers. When we multiply them, they'll give us negative 8, but when we add them, they'll give us negative 2, and that is negative 4 and 2. If we multiply these ones, they'll give us 8. If we are going to add them, they'll give us negative 2, which is our product, our sum in that case. Okay, so let's just do that. Okay, so what are we going to have? Okay, what are we going to have if we factorize this one? We're going to have x minus 4. That's the first part. Then we have x plus 2, because those are our factors. This is equals to 0. Okay, so what are we going to have? We have x minus 4 is equals to 0 and x plus 2 is equals to 0. So x in this case will be equals to 4. X in this case will be equals to negative 2. So these are our critical values. So it means we don't want in this when we're finding the domain, we don't want these values. We don't want positive 4 and we don't want negative 2. Those are the values that we don't want. So what are we going to do? If I was to draw my diagram, let me draw my diagram here. Let me say this is our Cartesian plane or our x or y plane. Okay, not really drawn to scale. Let's say negative 2 is here. Okay, so we don't want negative 2, so we'll show arrows like that, meaning we don't want this. And let's say we also don't want 4. Let's say 4 is here. Okay, so how are the values going to look like? So I find that we want everything going this side, but we don't want to just touch 2. Want everything this side, but you don't want to touch 4, and you also want everything this side, but you just don't want to also touch 4 like that. Your asymptotes like that. So it means the domain for this case, our domain for this case will be, we're moving from negative infinity to negative 2. That is our first one, and we don't want 2, so we'll put these open brackets, union. Let's come on the middle from here to here. So it will be negative 2 to 4. Okay, now let's come to the last part from here to going this side. So this will be union. This is just from 4 to positive infinity like that. So this will be our range for this case. Okay, let's also solve D. D is saying f of x is equals to 3 over x cubed minus 16x. Okay, so the denominator, like we've said, this is a rational function. It's a fraction actually, so the denominator cannot be equals to 0. So we'll say x cubed minus 16x, this should not be equals to 0. So what are we going to do? Let's factorize. So we'll say x squared minus 16 to be minus 16, right? Okay, this should not be equals to 0 like that. Okay, so what this means is that okay, we can also factorize in the brackets also of x squared minus, this is just 4 squared, right? Okay, and we can also simplify it further, where I say x squared is equals to in your brackets you have x minus 4. This is the difference of two squares, and x plus 4. This should not be equals to 0. So these are the values that we don't want. We don't want x is equals to 0. Okay, let me use a different color just to make, we don't want x is equals to 0. We don't want x is equals to 4 or negative 4, and we don't want x is equals to 4. So we don't want these values. So now how can we let me just show, maybe using a diagram to make things easier for people. Let's say, okay, let me just use the red color now. Okay, this is our nope. Okay, let me say this is the y-axis, this is the x-axis. Okay, so we don't want negative 4. We don't want our 0, 0 is here, right? We also don't want our 4. So if we were to draw, we don't want this. If we wanted it, we would have indicated with a very solid line, but we are showing dotted lines like that. So now what do we want in this line? So want everything, so your values will be moving like that, approaching this asymptote like that. Then when you come to the other side, because you don't want 0 as well here, so in this side you just want this area going like that. You shouldn't touch these lines, okay? Not really drawn to scale. Okay, then even in the other end, you want this area shouldn't touch your 4, and it goes like that, and it shouldn't touch your 0 like that. When you come to the other side, okay, it shouldn't touch your 4, but it's going to your vertical, your horizontal asymptote like that. So that's what we're talking about. So it means now the domain for this expression, okay, let me just wrap the domain for this expression. So your df in this case would be you're starting from negative infinity to negative 4. Now negative 4 is not included, so union negative 4 comma 0 union 4, and you're going to positive infinity like that. So this will be your domain for this expression. Okay, that was question number 2. Let's solve another question. This is question number 4. Is it? Okay, that is question number, okay, that is, we solved A, we solved, okay, now we're on question number 4. Okay, find the range of each of the following functions. Find the range of each of the following functions. And I don't know if we've solved all the questions for the other previous question, just to make it clear. Okay, we didn't solve E. We didn't solve E, and we didn't solve F. Okay, we didn't solve E, and we didn't solve F. Okay, I think let's also solve E and F, just to make it easier for people, because others might find it hard. Okay, let's proceed. Let me use my next page that I used. Okay, so let me just erase here. So our E in that case is f of x. F of x is equals to the square root of 2x squared minus 5x minus 7. So we're trying to find the domain. So the square root function is defined only if the expression inside is non-zero, like we said. Is non-negative. You don't want to have a negative in this expression, because you don't want a complex number. So what are we going to do? You're going to equate this to be equals to 0. So you say 2x squared minus 5x minus 7, the square is equals to 0, is greater than or equal to 0. So now this is a quadratic expression, so we're going to solve this quadratic expression. So how do we solve a quadratic expression? We say x is equals to, just to remind you, negative b positive or minus the square root of b squared minus 4ac. Now this whole expression over 2a. Okay, so let's solve. So we're saying our x is equals to negative, we're saying negative b. Negative b in this case would be what? To be negative 5, because this, we remember the expression ax squared plus bx plus c. So our negative b in this case will just be, it would be 5, right? So this is negative 5. Okay, positive or minus the square root of, okay, the same b, so this is negative 5 squared minus okay, our a in this case, our a in this case is what? Is 2. Then our c in this case is negative 7. So we solve x is equals to, okay, negative and negative, this will just give us positive 5, right? This is positive or minus the square root of let's say negative 5 squared, that is 25. Okay, plus, okay, this is negative 7 multiplied by 2, that is negative 7 multiplied by 2, that is negative 14. Negative 14 multiplied by negative 4, that is 56. Okay, so how are we going to now solve? And when we add what is in the brackets, 25 plus 56, this is just 11, this is 8, so 81. And the square root of 81, the square root of 81, that is just 9. So okay, let's, the square root, when you do this, it will give us the square root of 81. The square root of 81 we're saying is just 9, so this whole expression is just 9. So let's just do that because of space. Okay, so we're saying this will give us 9 like that. Now this whole expression, don't forget, is over 4. How is it over 4? Because we're saying it's 2a. Our a in this case is what? Is 2. So this will give us 4. So okay, it was over 4 throughout. So this will be over 4. So how are we going to now solve? 5, positive 5, let's say positive 5 plus 9 will give us positive 5 plus 5, that is give us 14 over 4. That would be our first expression. Or positive 5 minus 9, that will give us negative 4. So negative 4 over 4. Negative 4 over 4 do give us negative 1. Okay, let's see what we have. Okay, let's see what we have. So we found that x is equals to 14 over 4, and x is also equals to negative 1. So we can also reduce this one. 14 over 4, it can give us let's say 14 into 4 into 14, that will give us like 3 point that is, remember, 4 into 20, that will give us, that would be 3.5. Okay, at least 3.5 is easier to plot. Okay, so if we were to plot this graph, just for just to give us a context of how our diagram looks like, since it's a quadratic, so it will open like that. Okay, yes, it will open like that, and it has shifted 7 times. You remember it was 2x squared minus 5x minus 7, so it had shifted like negative 7 times. So this would be negative 7 here. Okay, then we found our x to be negative 1, so negative 1 will be here. Then we found our x to be negative positive 3.5, so our 3.5 will be on the other side here, 3.5. Okay, there's a turning point somewhere, but we're not really interested in finding the turning point, right? So now we're going to now again do the same thing where we want to find where x and y exist. Okay, but even just from this expression, we're able to see that the domain Okay, without wasting much of the time, the domain for this case, okay, what are we going to do? Let me just erase. So the domain for this expression will be, okay, so let's try. So the domain for this expression will be because you're starting from negative infinity and you're going this side, right? So it is you know, from let me see, it will just be from negative infinity. This is negative 1. Now negative 1 will be included, okay, union, okay, this will be included as well, 3.5, because we want numbers that are greater than or equal to 0. Okay, so what are we going to do then? This will be we're going to positive infinity, like that. Okay, so let's now solve question 4 that we didn't solve. Okay, find the range of each of the following functions. We're trying to find the range of each of the following functions. So the range refers to all the possible values of f of x or your y. Your output, like we said last time, your x values are your input, which is the domain. Then your y values, these ones are just, you know, we call them the code domain. But if all of them are mapping, if every x value has a y value, to be called the range, like that. So I'm trying to find the range of each of these functions. Okay, so let's solve. Let's start with the first one. Okay, so our A is saying this is f of x is equals to x squared plus 7. Okay, so how are we going to find the range? Now we're trying to find the range of each of the following functions. So we have to first know the form of the function before you solve, and it gives you, you know, a clear picture. You are able to see that this is a quadratic expression. Okay, so the form of this function is a quadratic function, and you know, a quadratic function has the form f of x is equals to ax squared plus b, this expression that we have. So where your a in this case is greater than 0, meaning it opens upwards. It opens upwards, like that. Okay, let me just also draw to just to put this into context. If you are going to draw this expression, if you are going to draw it, let me say this is your then this is your expression, like that. Okay, and you're able to see that it has moved 7 times. It has shifted positive 7. So it just means at 7, that's where your turning point is, and it's going like that. So only at 7, like that, and you're going like that. You're going like that. So that would be like your expression of the graph. Now what's the minimum value of this function? So the value of, you know, x squared should always be non-negative. We want, you know, to have positive. We want x squared to be, you know, it's always greater than or equal to 0, because even if you say we put a negative in this expression, negative x squared, it will always be greater than 0. Whatever, even if it's a negative number or a positive number, it will always be greater than 0. And we are now also adding 7 shifts on top of that. So it means your f of x will just be greater than or equal to 7 in this case, and that will be the minimum value. So the range in this case will just be from 7 to positive infinity, like that. Okay, this one is just a quick go ahead. Okay, now let's solve number 2 on this same page. Okay, our number 2 is we're trying to find f of x is equals to 16 minus x squared. Now the form of the function, you have to always know the form of the function. So this is a quadratic function. Now this is of the form f of x is equals to negative x squared. So because it's negative, so you just have a plus c, unlike the one that we had. So in this case, the negative, it just indicates that it opens downwards. The other one, the first one, this one, because it was a positive, it was opening. If you saw, it was opening like that. Now because here there's a negative, so it opens downwards. Okay, so let's solve. We just try to put into context. What am I saying? Okay, if we were to draw this one, okay, before we even start solving, if we were to draw this one, okay, let's first solve. We find so that we find the critical points. Okay, so how are we going to find the critical points? Okay, so our f of x, in this case, we are saying our f of x is equals to 16. Let's say if we're going to find our f of x, we're saying plus is minus. If we're just finding the f of x, the y value at that time, when we replace x by 0 to just be, so our f of x, in this case, our f of x only will just be 16 like that. But now how do we find our x values? So just say 0 is equals to 16 minus x squared, because we're trying to find our x squared. Okay, so what are we going to now do? Okay, this is just the same as you're just saying, okay, 16 goes to the other side, so you have 60. This is it negative 16? Yes, negative 16 is equals to negative x squared, and the negative will cancel. For it to remain with your x on this side, you should find just the square root of 16, so your x will be positive or minus 4, right? So these are our critical points. Okay, so let's just try to draw this. Okay, just to put context to what we're talking about. Okay, it's easier when you're able to draw the diagram. Okay, so we've got a negative 4 here, and we have a positive 4 here, and we are saying at 16, at f of x is equals to 16, that's where your graph is making the turning point like that. So this is 16. So if we were to draw, we said this graph, because of its form, it's a negative, so it is opening downwards like that. So it will pass like that, not really drawn to scale, but it will pass like that and go like that. Okay, so in this case, what would be the range of what would be all the y values? So you are seeing that all the y values, they're just starting from from negative infinity. So the range, in this case, the range of this function will be from negative infinity, it's going to positive, like it just end at like at 16 like that, this one that we found like that. Okay, is there any other question that we can solve on this one, on the range? Okay, let people understand the range because of their test that is coming. Okay, let's also solve another question. Let's solve C as well. Okay, so C is f of x. F of x is equals to 2 over 3x minus 4. So now we're trying to find the range. Now what's the form of this function? What's the type of this function? This function is it's a rational function, right? It's a rational function. It's just a fraction like that. Okay, a function that is the form of a fraction like that. Okay, so now how do you find the range of a rational function? So what do? You have to find the inverse of this expression. You have to find the inverse of this expression. Then the other thing is that the denominator, that the denominator should not always be equals to 0, right? So in this case, if you're going to, you say you're going 3x minus 4, this should not be equals to 0, right? So x in this case will just be, x should not be equals to 4 over 3 when we do that. Okay, now the behavior of this function as it approaches as x approaches this and 4 over 3 from either side, you realize that the function tends towards the vertical, like asymptotes, and the function can take any real value except 0, because we are saying this 2 over 3x minus 4, this expression should not be equals to 0 for any value of x. Okay, for any value of x, because you don't want it to be undefined. So in this case, the range will just it will just exclude 0. If we were to draw this, let's find the inverse of this function to find the range, so that we find the range. Okay, so if we say y is equals to 2 over 3x minus 4, and okay, we make x a subject, so we have 3xy minus y is equals to 2. If we make x a subject, what are we going to have? We have let's say we have x, you know, x, we're saying x is equals to, if we're going to do that, we have 2 over 3, is it y? How have I done it? Okay, this is okay, 3x. Okay, okay, let me just solve it step by step. Okay, so we're saying, okay, so on this other side, this should be equals to 2. Okay, so what are we now going to do? If we're going to make our x subject to the formula, okay, what are we going to do? So we have on top, we have 2 plus y over, then we're going to divide by 3y, right? So this will be our x. Okay, if x is like that, because what we've done is we've taken the y to the other side, it has become positive like that, then we've divided by 3y to remain with our x like that. That's what has done. That's what has happened. Now this is the one that you equate to 0. So you remember the domain is the input, then the range is the output. So when you find the inverse of that function, that's when you're able to find now the output. So that's what we are doing. So this 3y should not be equals to 0. So y, in this case, if you divide by 3 on both sides, so y should not also be equals to 0. You understand what we're talking about, right? So this will be our range, the one that we're equating this expression to 0. So meaning y is equals to 0, and we don't want 0. So for this scenario, what are we going to do? So our range in this case, because we want everything, but we just don't want the 0 that we found for y. So in this case, our domain, or our range in this case will be, you're saying, you know, your range for this case will be, you want all the values, so from negative infinity, but you don't just want 0. So because you don't want 0, so again union from 0 to positive infinity like that. You just don't want 0, the 0 that we found. Okay, so want everything except 0. That's what I'm just trying to say. Okay, then okay, should we solve these other ones as well? Okay, which one looks complicated? Let's solve E. Let's solve E. Okay, so E, okay, E, F, Shanshan, F, Shanshan. Okay, seems like we have a lot of questions. Let me also proceed. Let me just proceed. We do a lot of questions as possible, but that's the same expression, the way we've just been solving these ones. Okay, I've just seen like it will also take a very long time for us to finish. Okay, so let's also solve other questions. Okay, we have 5 here. If f of x is equals to 2x squared minus 3x plus 1, g of x is equals to 3x plus 1, and h of x is equals to the square root of x squared minus 4x, find fog of x. Okay, now you remember that your fog of x, this one just means f, but f, and you are inputting the g of x function, where the function itself gf in this case is substituted into f of x. Okay, so what are we? Let's solve the first one. So if we're going to solve that one, we say fog of x, this one. Okay, our g of x, they are saying our g of x equals to 3x plus 1. Okay, so now, and our f of x is equals to, our f of x in this case they are saying is 2x squared minus 3x plus 1. Okay, so we are inserting this one into this function. Okay, so what are we going to do? So we'll say, so what are we going to have? We'll say our f of x, or f, let's say fog of x, will be equals to, okay, so we'll say 2, so wherever there is x, we'll be replacing your g of x. So your g of x in this case is 3x plus 1. Okay, the first expression is squared. We're done with this one. We come up a negative. Now we do this, so it will be 3. Okay, so what is our x? We're saying is our g of x is 3x plus 1. Okay, then what are we going to have? Plus 1 at the end. Okay, now let's solve this. Okay, when we solve this one, what are we going to have? Okay, that is okay, we have our 2 here, and if we were to multiply, okay, so we just say 2 multiplied by 3, that is 9, and 2, like we usually do, the way we just do it quickly, this is your 2, so just make your 3 squared and your 1 squared. So if you say 3 squared, that is 9, and at the end, at this end, you see, it will just be 1 squared, that will be, it will be 1, like that. Then in the middle, you say 2 multiplied by 3, and like that. So 2 multiplied by 3, it will give us that will just be 6. So this is 9x plus 6x plus 1. Okay, minus, on the other side, if we do our multiplication on the other side, we can just say negative 9x, negative 3 again multiplied by the 1 there to be negative 3 plus 1 at the end. Okay, let's solve. Okay, what are we going to have if we solve the this expression? Let's write it on top. We've got 2 9x plus 6x plus 1 minus 9x minus 3 plus 1. Okay, this is plus 1. Okay, so what are we now going to have? If we multiply, if we distribute 2 throughout the bracket, so this will be 18x plus 12x plus 2 minus 9x minus 3 plus 1. Okay, so let's simplify this. What are we now going to have? Okay, so in this case, what's common? Do we have a squared anywhere? Okay, I think we left a squared somewhere here, because where was it? Yeah, here when we're doing we're doing 3 squared like that, even 1 squared. Okay, this is squared and 1 squared was like that. So even this x is supposed to be squared and this x is supposed to be squared like that. Okay, So we're just going to remain with, let's say, 18x squared. Okay, then what are we going to have? This is 12x minus 9x. That will give us 3x. Okay, 3x. Then what now remains? Here we've got negative 3 plus 1, that is negative 2, negative 2 and 2, that will just cancel out. Then we'll remain with our 12 like that, plus 12 like that. Okay, okay, now let's solve another one. Okay, let's just reach to question 6, then the other part will come later. Okay, okay, B, let's say, you know, we're solving fog of negative 2. That is this is it B? Yeah, for fog of negative 2. So how are we going to do that? Okay, we just use the same expression, the one that we're just from finding, I think. Yeah, and you substitute into that, and you're going to get your answer. Okay, so we found something like, you know, our f of because we're finding fog, we've already found fog, but now we're finding fog of negative 2. Okay, so our fog of, you know, negative 2 in this case will be the 18x squared that we find plus 3x like that. Then you just replace, you know, your negative 2 in this expression, and you find your answer like that. Okay, which other one can we solve for this one? Is there anything that we can solve? Golf, there is golf. C, on C we've got golf. Should we solve this one? Okay, we just want those ones which look complicated, the ones that you can solve. Then the ones that you fail to solve, you can still reach out. Okay, we got golf. Okay, let's solve golf. Okay, we're saying f of x is equals to 2x squared minus 3x plus 1. Now we are inserting this one into g of x like that. Okay, so this is like the opposite of the one that we did first. So what are we now going to have? So we say g of, you know, 2x squared minus 3x plus 1. This is equals to we're saying 3, wherever there is x will be replacing by you know, f of x, and our f of x in that regard was 2x squared minus 3x plus 1, then this plus 1 outside. So let's simplify this expression. Okay, so what are we going to have? We're going to have, if we distribute 3 throughout, it will be 6x squared minus 9x plus 3, okay, plus 1. So what are we now going to have? We're saying 6x squared minus 9x plus 4, right? On the other side. So can we simplify this one further? No. So this is where we end. Okay, let's also, okay, there is also, you know, if there is let's say there is FOH. Okay, we haven't solved anything for H. Okay, let's this one be the last one just for H. Okay, so we're trying to find F. This is D. Okay, we're trying to find that expression. So our h of x is the square root of x squared minus 4x, and now we want this one into f of x. We want to insert this one into our f of x. So what are we going to have? So let's just write it here. Let me use a different color. So you know our f of x is our f of x is 2x squared minus 3x plus 1. Okay, so what are we now going to have in this regard? We're going to say, what are we going to say? Yeah, we're saying 2, wherever there's x, we'll be replacing that expression. So it will be the square root of x squared minus 4x, okay, is this squared? Okay, is this squared? Okay, we're saying that. Okay, this x is squared. Okay, so this is squared. Okay, minus 3. Again, our x is the square root of x squared minus 4x plus 1. Okay, so now let's solve. Now what are we going to like have now? Okay, so let's solve. So we have 2. Okay, you just know that this squared and the square root will cancel, right? So in this, you just remain with x squared minus 4x in this first expression. So you have 3 and plus this whole expression. So let me just write it like that, x squared minus 4x. Okay, this is like that. Then you have your plus 1 like that. Okay, is there anything that we can simplify from here? Okay, we can distribute the 2. So if we say 2 multiplied by that would be 2x squared minus this would be 8x, minus 3, the square root of let's say x squared minus 4x plus 1. Okay, so can this be simplified further? No. Okay, so here that's where we end from for this expression. Okay, okay, so let's solve the last one just for this session, so that we just make the other ones in another session. We don't want the video to be very long for you guys to confuse you. Okay, question 6 is saying the function given below are either 1-to-1 or not. If the given function is 1-to-1, find its inverse. If it's not 1-to-1, limit the domain by finding the largest possible subset so that the function is 1-to-1, and then find its inverse. In each case, state the domain and the range of the function and its inverse. Okay, now this one is very interesting. Okay, so we're finding almost everything. So 1-to-1, the domain, and if you don't find it's 1-to-1, you have to restrict the domain. Okay, so we've got, let's start with a. We're saying a is equals to 8 over x plus 3. Okay, and our domain is this the, so yeah, a, actually that's how it is. Okay, x, it should not be equals to -3. Okay, I think there was a typo here. Okay, good. So now how do we solve this one? Now this is a rational function. It's a fraction, but in terms of a function. So for rational functions, like we've said, okay, this one is just a 1-to-1 function. Okay, so it's 1-to-1 because it possesses the horizontal line test. Each input, x value always give a unique output value like that, for a function like that. Okay, so let's find the inverse. Okay, let's find the inverse, because the question was telling us if it's 1-to-1, you have to find its inverse. Then if it's not 1-to-1, you limit the domain by finding the largest possible subset. Okay, so because we've identified that this is a rational function, and the horizontal line test still, it will still like agree. So what are we going to now do? Okay, so because if we were to draw this one, although we've not been taught to draw, because I like drawing just to illustrate so that we don't leave anyone behind. So we've seen like x should not be equals to -3. So if x should not be equals to -3, if we say this -3 is here, and if we draw a line, a dotted line, because we don't want -3, Why don't we want negative 3? Because we don't want this our denominator to be equals to 0. So if you put negative 3, if you say negative 3 plus 3, to give you 0, and you don't want a function to be defined. So we want everything, but we don't want negative 3. That's what we're talking about. Okay, so let's just do that. So how are we going to do the function? Because we don't want negative 3, so our graph will just go like that, but it shouldn't just touch like that. Then again, it will also come the other side, but it will not touch negative 3 like that. What we just want is just negative 3. So now, how do you now find the range? So the domain we've already found is x should not be equals to negative 3, and it's all real numbers, so just include all the real numbers. But now, how do you find the range? Okay, so how are we going to find the range for this function? So you have to find the inverse of this function. So say y is equals to 8 over x plus 3. So what are you going to do? You're going to make y the subject of the formula. You're going to make x actually the subject of the formula. How we find the inverse? So we say when we multiply this y multiplied by this expression, okay, what are we going to have? So we say, so you have, okay, we're saying this is x plus 3. So if we're multiplying this by y, so you have xy or yx, whatever you want, whatever resonates with you. 3y is equals to 8. Okay, right? Yes. Okay, so now what are we now going to have in terms of x? Okay, I also use just an expression. So our x in this case will just be, we say 8 when the y the negative 3y, when the negative 3 goes on the other side, what are we going to have? What are we going to have? Okay, so to just go there, the other side, negative 3 will go the other side, and you have over y here. Over y actually, not what I've written. Over y like that. Okay, so in this case, this will be our inverse. And if you look at your inverse, this would mean like if you are going to equate the denominator, you're going to realize that this y, because y is just down, so y shouldn't be equals to 0. Okay, y shouldn't be equals to 0. Okay, y shouldn't be equals to 0. So if y shouldn't be equals to 0, that would be our range. So now how are we going to show this one? So we are going to do this. Okay, so our range in this case and our domain, just to represent it fully. So your domain for this expression will be want all real numbers. X should be a member of all real numbers, but it should not be just equals to 3 like we said earlier, to negative 3 actually, to negative 3. So negative 3 should not be equals to negative 3. Then the range for this function, your f of x in this case should just not be equals to 0 like we found the inverse. Okay, then if you're finding the range of the inverses, just the opposite of these two. Okay, they just alternate like that. Now let's solve b as we are closing. Let's solve b. Okay, so if we're saying f of x, for b we're saying f of x is equals to 6 minus 3x. Now 6 minus 3x, this what form of a function is this one? This is a linear function. So if it's a linear function and it passes through a horizontal line test, meaning it's also a one-to-one, because all the values of x, they exist. For a linear function, all the values, there's no value that you can put here for x that won't exist. If you put a negative number, you still get, even if you get a negative number, like what you don't want is just for a function to be undefined and to have a negative root. So all the values that you can put for it exists for anything. So the domain for this case, we've already found the domain. So just say domain for this function will just be x should be a member of all real numbers. Of all real numbers for the domain. Then let's find the range. So the range, again, you're just going to say y is equals to 6 minus 3 x, like that, and you make y the subject of the you make x the subject of the form. This side you have y minus 6 is equals to negative 3x. For it to remain with x, you're going to divide by negative 3 on both sides. So our x in this case will be y minus 6 over 3. Is it? Why? Yeah. What have I done? Okay, so now what are we going to have? So the inverse in this case, so you're also like, okay, you only have a constant here down, so it means y exists also for everything. So now what are we trying to do? They're trying to tell you that for a linear function, the domain is it exists for everything, and at the same time the range also exists for everything. So in this case, f of x, is a member of all real numbers as well. All real numbers will still exist for f of x, like that. Then let's try to find anyone which can try to maybe find where we can restrict the domain or stuff like that. Okay, let's try C probably. Okay, let's try C so that we see where we can go. Okay, so let's solve C. We are saying our C in this case, we are saying f of x is equals to x squared minus 8x, and your x in this case should be less than or equal to 4. Now this is a quadratic function, and like we said, the quadratic functions are not one-to-one over the entire domain. So because they are not symmetric about their vertex, or because they are symmetric actually about their vertex. So if let's try to draw this in, because I like drawing, like I've said, just to so just be good at drawing graphs. Math would be nice. Okay, so we've got a negative 8 there, and we're saying x is equals to 4. So there our turning point. Okay, so what are we going to do? Because it's here the coefficient of x is a positive, so this will just open upward like that. Okay, now what values are we going to have? We are saying x should not be equals to 4, because we don't want x to be 4. So what are we going to have? X is less than or equal to 4. So let's say this is 4 here, right? So draw a solid line. This time we're drawing a solid line, we're not drawing a dotted line, because x is less than or equal to 4, like that. You draw a solid line on 4. Let's say this is 4. Okay, then these are you have a point here, you have a point here, you have a point here, which would be like your turning point. Let's say you have another point there. Okay, so what are we now going to do? Okay, so the behavior of this function, we're saying x should be less than or equal to 4. So where is x less than or equal to 4? It's this side, right? That's where x is less than or equal to 4. So this is the part that you want, because this thing gives you a symmetry. It's just that I've not drawn it to scale. Let me just draw it again. Okay, so we've got an expression like that. This is a y, this is the x, then this is, let's say this is a 0. So this graph will pass like on 0, then it goes like that. Now here we've got 4, we've got 4 here. Okay, this is 4, and we don't want everything that is this side. We don't want everything that is, actually that's what the x is less than. It's less than or equal to 4. So now the domain for this case, you know, just because you're starting from here and you're going this side, so the domain for this function will be what? Because you're going to negative infinity, right? So it be, because you're going to negative infinity, so it will be negative infinity, you know, comma 4. But now 4 is included, and negative infinity is always put like that, like we've already said, because you don't know what negative infinity is. So like that. So this will be our domain for this case. Then how are we going to now find the range after we've restricted the domain? Okay, we're going to make x squared minus 8x. We are going to solve using, probably this is a quadratic expression. So you can solve it using completing the square or the other quadratic expression, the formula like that, whichever resonates with you. But for this question, mostly you are supposed to usually use expression, the completing the square, because you want, there's a certain form that you want. Okay, let me just solve it quickly. So how are we going to solve this one? Using completing the square. So we say y is equals to, okay, so we got actually we got x squared minus 8x. So how do we usually solve this one? Okay, so for completing the square, we usually, the coefficient of x, this one, you half it, then you square it, then you put that in brackets, then you add, you add and you subtract. That's what we usually do. So in this case, I'll just do it quickly. So to just be x minus let me say x minus 4x squared. In this case, it will just be y plus 16. X minus 4 in this case will be equals to negative the square root of y plus 16, because we just want to cancel this like that. So we're going to do like that, right? So you just remain with that you just remain with x minus 4. So our x in this case will be 4 minus, because the taking for the other side, 4 minus this expression. Okay, 4 minus that expression, so 4 minus the square root of y plus 16. Okay, so now how are we going to simplify this one? Okay, so for completing the square, guys, you just have to know. Okay, so what are we now going to do? So we are saying we've remained with x is equals to 4 minus the square root of y plus 16. So what are you now going to do? So our f inverse of x in this case, we can just do it quickly, where we say it's the same expression. It's the same expression, 4 minus the square root of x plus 16. In this case, x should be greater than or equal to 16. Why am I saying this? Because of this, you know, this is a radical expression. You have a root here, and if you put 16 where there is x here, if you put a number like less than 60, greater than or equal to 16, it will give you a negative expression. So you don't want that. So that would be like our range now for this function, because that's the we found the this is the function that we found. But now do you find the inverse? We found the inverse, but now you have to find the range. So the range, you target where the expression is here, the root, like that. So now what would be the domain and the range for this function? So the domain we've said, you know, it exists, but we just don't want 4. Okay, so from negative infinity to 4, then your range, or your range for this function will just be from negative infinity, but like we say, you just don't want negative, should be negative 16, like that. You don't want okay, so this is where we end from today. Thank you.